In this video, we will talk about command and process substitution, as well as here string and here document in Bash. Command substitution allows the output of a given command to be replaced by the command itself. So let's take the example of the echo command here, for instance, where I want to print a message indicating the username that is executing the command. And I know that there is a tool, Who Am I, that allows to return the effective username of the current user. So to get this username, I need to run this command and use the output of this command inside my echo command to show the message. So it allows to run a command in a composition with other commands and directly replace the command by its output. So if in my script here, I just try out username is, then who am I? So basically, who am I would be executed, and the result of who am I would be returned inside this string, and that is what will be printed. So we can first check what who am I shows on its own. It prints Doe because Doe is the current user that is running the command. So when running this script, then we have username is Doe altogether. So the command itself gets executed inside the subshell, and the output of the command is used to replace the command substitution construct. Apart from the $parenthesis construct, it's also possible to use the backquote, or also called backtick, to perform command substitution. So instead of $parenthesis, I can use the backtick. So it's this construct here, it's not much obvious, right? But it can also be used to perform command substitution. So if I run the script again, then we get the exact same result. But I will recommend to use the $parenthesis because it's easier to read and more obvious. Let's check what we currently have in this working directory. We have a set of bash scripts, and let's say as an exercise, we want to print out these scripts without the .sh extension. Yeah, each of them has a .h extension. Let's say we just want to print the name of the scripts and maybe print the name of the scripts in all uppercase, for instance, right? So it means that we need the output of the ls command, and we need to pass that output of the ls command to some other command to be able to trim off the extension of the files and convert the file names into uppercase, let's say, all uppercase. So for this, there are different ways that we could do it. So let's say we use the for construct. With the for construct, we can do something like this. So for file name in, so we want the output of the ls command. So we use the command substitution and write ls. So this will execute ls and replace all the files that have been read here, and then do. So let's first try to print out the file name to make sure that everything is working as expected. When we execute the script, then we have the files printed one per line, which is the expected result because ls will return the list of the commands, and for each iteration, the file name variable will successively take the value of the name of each file, and then it will be printed out. So this would be equivalent if we have, for instance, run ls, copied the output, and replace it with the $parenthesis construct, and let's execute again. The output will have been exactly the same. So instead of listing manually the contents, then we just want here ls to perform it, and bash will handle this. Bash will execute and automatically replace the output of the ls commands in line, and then execute then the for loop. And this can be done for any command to write like complex to compose multiple commands together. So for our small exercise, we wanted to trim off the extensions and convert the name in uppercase. And for that, we can already use variable expansions that we have previously seen. So let's say for file name, we want to trim off the extension from which is at the end of the file. So file name, and to trim off something from the end, we use %. Actually, 1 is good, and then we want to trim off .sh. And we can also use variable expansion to convert to uppercase with the double caret, and then print the file name. And let's run again, and then we have the extensions trimmed off and the variable names automatically converted to uppercase. So that's a small example of how command substitution can be used and composed with other commands. And maybe another interesting command, let's say that we want to create an indexed array that will contain the file names. Instead of having a for loop directly applying the command substitution, we can declare an indexed array with the dash lowercase a, and then let's say all these files, and we know for declaring the values of an indexed array, it should be between parentheses, and inside the parentheses we want to run our ls command. So this would be replaced with the list of variables and would declare our files associated array, and we can print all the files with the array expansion, and using the @index to return all the elements of the array. This will also work fine. So it's quite flexible, how it would be used. So here we have this printed out here, files with the list of the files. So basically we can index each element flexibly. Let's say file 1 would be at index 0 of the array, and let's say file 2 at index 1, and so on. Add an equal to make the separation obvious, and then that's it. So at the index 1 we have our first variable, at the second index we have our second, and so on. So very flexible and practical to compose multiple commands together and use the $parenthesis for the command substitution. Easier to read in scripts. And it's also possible to do substitution for arithmetic expressions. We have already seen the double parenthesis construct that allows to perform arithmetic operations. So let's declare an integer called index that I will set to, let's say, 29. And let's say index ++ to increment it, and here we'll show the value of index. And this is, we have already covered this before. It means that we perform first the operation that automatically increments the value of the index, and then we print the value afterwards. Add this. echo for this, and then we have our index printed, which is 30. And we can also use plus equal to assign, and then it executed and our index is 107. But let's say instead of having this on a separate line, we want the output directly to be composed with the echo command. In that case, we can use this and use the dollar with double parentheses. Or I can remove the double parentheses because I copied them already. And this will execute the operation on a single line and print the result at the same time. And then we have automatically the result. So we no need to separate the incrementation or the arithmetic operation and then print the variable afterwards. Yeah, it's possible to use them all together with the dollar double parenthesis construct, and then the result is automatically substituted inside our string here. And that's also pretty handy. Then we have less commands altogether at the end. Now with the process substitution, Bash allows to establish an inter-process communication between two separate processes or two separate commands. And the way it works is using pipes. And basically in Linux, pipes are a special type of files that allows two processes to exchange data between each other. So a pipe is a first in, first out type of kind of buffer, where a process can write into that buffer and another process can read from it on the other end. And a process, when the process is reading from a pipe, the process hangs as long as there is no data inside the pipe. And as soon as there is some data available, then reading from the pipe is successful, and then the process can continue with its execution. And that offers two syntax for performing process substitution. And the first syntax is with the left arrow and parenthesis syntax. So here we have two commands, command 1 and command 2. And command 2 is defined between the parentheses of the left arrow, right? And notice that between the left arrow and the opening parentheses, there is no space. They have to be written all together. Otherwise, this will be a redirection, right? So the left arrow and the parentheses are written together, and the commands to execute is written between the parentheses. And both commands are actually executed in parallel, and the output of command 2 is written inside the pipe, and the path to the pipe is provided as input parameter for command 1. So basically, if command 1 reads the file or the pipe, then it's getting the output of command 2. So the example here is with the cat command. So if we use cat left arrow with the ls command, then cats will execute with as input parameter the path to the pipe that will be created by Bash. And ls will also be executed, and its output will be redirected to that pipe. So as long as there will be no data inside the pipe, the cat command will hang and will be waiting. And when ls will have written its output inside the pipe, then the cat command will be successful and print out the output of the ls command. So if we execute, we just see the list of the files present in the current directory, which is just coming from the ls command. But to have a look a little bit of what is happening, we can just use echo here. Since echo will just print all of its input parameter, we'll see that echo will just print out the path that was being provided actually to the cat command, right? And this is the path to the pipe where the output of ls is written to. And we can even use ls itself to have more details about this path. And it is actually a symbolic link with pipe as it's being shown here. And that's how it operates. So if we want to show a little bit what is happening under the hood, then it would be something like this. So we have, let's say, here is command 1, and here is command 2. And if command 2 just run ls, and what it's doing, it's redirecting its outputs into, let's say, file.pipe, right, which is this in the arc4. And the second command 1 is doing, in this example, ls-l file.pipe. So the pipe where command 2 is writing its output is provided as input for command 1. And this is what is being done with this single command here. And both are being executed in parallel. So this ls command and this both are executing in parallel. And the first one, which is command 2 here, is redirecting its outputs to the pipe. And the command, the second command 1 is using that pipe as an input parameter. So basically, if we replace the ls with cat, then cat will be reading that file, and the content of that file is nothing than the output of this ls command, right? And that's how the first sentence with the left arrow parenthesis for process substitution operates. The second sentence is with the right arrow parenthesis, and this is a little bit more tricky because this time both commands, command 1 and command 2, also executes, and command 2 receive as input parameter the pipe. So a pipe is automatically created and provided to command 1 as input parameter, and also provided to command 2 as input. So if command 1 writes into that pipe, then everything that is written into the pipe is consumed by command 2 as its input data. And this we can actually have a feel of it with echo. Actually, we can already see what is a little bit more what is happening. Let's say I have 2 echo commands, then we see that this echo prints nothing, so I can just print example here, and this will execute and print example. And this echo command also execute even first, right, with the path to the pipe. So this echo receives the pipe as its input, and since echo just print out all its inputs, then we just have the path printed out, and this command is also executed. Here, nothing special is happening. So what we want to try now is to write a custom function. Let's call it loop, and it will just to create a loop. We create an index or a counter, or just call it count, and we want to loop while count is, or let's say, less than or equal 10, then we want to increment counts for sure, and we want to echo maybe loop count, and not to stress out too much, I will add some sleep 0.2 for instance, right? So it will just loop and print out the current counter value. And what we are also interested in are its input parameters. So basically its arguments. We want to see its arguments. We'll see all its arguments. And that's it. So if I copy this function and paste it in my shell, then I can do loop and then argument, there's nothing, and then you just loop from 0 to 10 and stops. Okay, perfect. That's what I wanted. So if to loop, I use the right arrow parenthesis construct, right? And added, let's say, echo here, which will just echo nothing, a new line. Then if I execute, now I see that the input parameter is the path to the pipe, right? And my loop just continue, and in between the echo printed nothing here. So if instead of nothing, I just say hi here between at some point, because it's asynchronous, right? At some point, it just prints, it executes this command that as both are running in parallel. This echo just executes, just print hi, and my loop continues and nothing special happens. But what is clear now is that this command receives as input parameter the pipe. And what we want to do now is to write some data into the pipe. So if I do hello from, and let's say func name, which is a special variable made available by Bash that refers to the name of the function, hello from func name, and then we want to redirect this into the input. One, since there is only one argument, it will just refer to the named pipe implicitly. So I can just do this pipe one so that we make sure it's sure that it's referring to the pipe. And this hello would be written into the pipe. So this means that this time, if I'll just put this into my shell instance again. If I run loop, right arrow parenthesis into cut, then cut, because the way it works is that anything that is written inside the pipe is provided as input for the command that is defined between the parentheses. It means that anything that I write from my loop command inside this pipe name would be provided as input, would be shown by cut. So if I execute this command, we get hello from loop, which is nothing else than the echo here that is being redirected inside the pipe. Anything from command 1 that is written into the pipe is provided as input argument for the command defined between the parentheses. Now we'll discuss about here string and here documents. Here string and here document offer the possibility to provide some input to command that expects some input file to use directly literal strings or variables, to provide some input to those commands. So instead of writing the string or writing the content of the variable first into a file and providing that file to the command, we can directly use the here string construct. We use the triple left arrow and then specify either the literal string or the variable that we want, and Bash will handle automatically the conversion. So the string would be provided to the command as if it was the content of the file already. So let's say with the cat command, since the cat command expects some input file, and we want to print hello world using the cat command, one way to do it, or the way we have seen before, is that it will be possible to use pipe hello world and pipe this and do cat, and then the hello world will be written into a pipe, and that pipe will be provided to cat, and cat will automatically show this, right? But this is not needed because this means that we are executing an extra command before executing the cat command itself. and this is extra, right? And that can be achieved using the here string construct with the triple left arrow. And Bash will automatically provide the string as if the content of the file to the cat command, and this will implicitly just execute as if we were providing a file directly to the cat command. And it can be combined with variables. So let's say I can declare the variable intro and call it and define the content happy learners. And instead of world, I want intro here, for instance, and print hello happy learners. And because with double quotes, every string in double quotes is subject to expansion, then the intro variable would be expanded, and then this will be provided to the cat command via the here string construct, as if it was a file with the string or the expanded string being the content. And this is very handy with commands that expect input files like grep, tr, cat, and what else. And if you already have your content inside a variable, instead of writing this content into a file first, you can directly use the here string construct and then combine it with what you want to provide. And it can also between the double quotes, I can also perform command substitution. So could be username and do who am I, and this is also fine. So run this, and we get hello happy learner, a username though. However, if I use single quotes, and this is a general principle in Bash, single quotes, with single quotes, there is no variable expansion occurs, right? I can also use single quotes, but my variables or command substitution will not be performed. So if you, the content should be literally presented as it is without expansion, then single quote should be used then. And the other construct is the here documents, and here's the here document construct can be made with the double left arrow followed by a delimiter string. Here it's doc. So let's use it with cat again. So we need to define a delimiter, and it should also end with a delimiter. And between these two, everything that is written would be subject to variable expansion and provided to the cat command as if it was written, it was being read from a file. Same principle as for the here string construct. So here we can do hello and then provide some variable. These will also be expanded, username, and who am I? Current path, pwd, and every kind of expansions can happen here. So I can even declare, let's say, an integer index 229, and here into index to the arithmetic expansion to index times 2, for instance, and all these will be processed, right? And provided cat or whatever command is defined in front of it as if this was being read from a file. And Bash handled this. for us implicitly. So we have the whole string printed, and notice that here my file is using spaces, right? And all the spaces are being shown. So if I want no space in front of it, I should remove the space myself, and then it would be directly printed as first. But with spaces will also, the white spaces are preserved. But variable expansion, command substitution, arithmetic substitution, all kind of substitution happens automatically. But the delimiter can be anything. So I can change it, make this end of file and make it end of file, as long as the delimiter that is defined here is the one that should be encountered to mark the end. And notice that there should be no white space before it. So if I add a single space even, then this will not be perceived as the end of the string anymore, right? So I can actually, the delimiter itself can figure multiple times, but only when it starts the line, then it's considered the end. So no white space is allowed before the delimiter, right? So here we see it printed multiple times because there is a single space in front of it, right? And it would be the first word on the line, and then it would be considered to mark the end of the here document. But if it's not desired that all the substitution to happen, then the first character should be quoted like this. If I add like double quote, for instance, none of the expansion will happen. So the string will just print it literally. Yeah, with all my dollar commands, variables, without them being expanded. So just add, not even if the entire delimiter is not quoted, but even a single word in it is quoted, then it will not work. Bash will automatically remove the double quotes, but no expansion will happen from the content. To have expansion, the delimiter should be written without any quotes, and then expansion then can happen. It's also possible, but only with tabs. So here I'm using spaces for indentation. So basically here it will not work. But if I'm using, I will just indent using tab and then convert indentation to tabs. So if I convert all my indentation to tab, then I can ask Bash to remove all leading tabs by adding a minus sign after the double arrows and before the delimiter string. And this way, all the leading tabs would automatically be removed before the string being printed. So if I run this, then it's printed as if I added no indentation at all, right? But it only works with tabs. So I added 2 tabs and it's just printed after stripping off the tabs. But if I convert everything again into spaces and use spaces for indentation, then my spaces will be converted. So white space is not removed, only tabs. Yeah, the white space are kept, although the minus sign after the double left arrows are present. So if I want to run grep to detect hello, I can do hello world using here string, and I can also do this way talk. This will not work. hello world. And doc, and then grep also detect my hello world, because grep expects a file, and the here string or here document convert literal strings after or string after expansion into a file directly to the command to be executed. And note that in between the here document, I can use quotes without problem. I can use quotes without it affecting, yeah, because quotes are not delimiting the document here. So the document itself can contain quotes. And it's actually a nice way if I want to write some JSON file, let's say. So here, since I'm using spaces, it will not be removed. But let's say I want to write some JSON file in Bash, then I can do name or username joining age 43. So this, for instance, yeah, can sharply build JSON using here documents, and this can be executed, and then we have our JSON documents.